My name is David Eaton, and I look after the engineer's file collection, which is part of the Hawley tool collection. My talk is about the history of file making in Sheffield during the 18th, 19th and the 20th centuries. File making came to an end in Sheffield in 1991 when the company of A.H. Ralston closed. The structure of my talk is shown on this slide. It starts with a video by Ken Hawley titled Files No More. This is followed by a brief history of Sheffield's early file-making industries. Files are made from tooled steel, so I cover early steel making by the cementation and crucible processes. I then move on to hand file cutting, where Ken Hawley demonstrates hand file cutting. This leads on to machine file cutting. Two file companies are discussed, A.H. Ralston and Thomas Firth & Sons. Hiram Younge was a brilliant file cutter and was famous for his exhibition files. He died at the age of 43 from a disease known as cachexia, which was a form of cancer caused by lead poisoning. Dr. Hall did a study of file cutters' diseases, and this illness was common. Finally, I mentioned the company of Wheatman and Smith, who made files and steel on the site where the Hawley Gallery is now. This is a video by Ken Hawley titled Files No More. Ken explains why files have disappeared to a great extent in modern manufacturing.
Metalworking has been done in Sheffield for 4,000 years. That's what seems to be apparent. So files have been made here certainly since the 17th century and maybe earlier. So probably it's because the source of the material that files are made from, steel, was made here. And it remained, like many other cutting tools, a major industry of Sheffield in the past. Now it's all gone, everything has gone. But here we have examples of various files that are being made. Before I go on to those, it might be interesting to know some of the reasons why it's all gone, why no files are made anymore. So, may I have the footwear apparel, please? This is my shoe. And this is the sole of my shoe. And this is moulded. At one time, all shoes used to be made of leather. And leather required special files and things called rasps, which is a type of file, in order to make them and repair them. And people who make bespoke shoes, very high class ones, will today still have files of that sort, possibly very old ones that they're still using. They'll not get any new ones. What will happen then, I don't know. So for all the shoe trade, no files are made anymore. This is a saw. This is a traditional saw that was made in Sheffield. And files were used in order to produce the saw and sharpen its teeth. It would be better to show me that way. So these are the teeth. And they were sharpened with a file, not exactly this, but similar to this. So each tooth was filed using that. And we have pictures of a saw manufacturer actually filing saw teeth with a file, each one individually. Later on, they were ground, of course. And today, they don't manufacture saws like this. They make them what's known as hard point. And once it's blunt, it gets thrown away. But also, the circular saw came in, that are now all handheld, and the jigsaw, a little blade that moves up and down. So saws of this pattern are now a thing of the past. So all saw files have now disappeared. Now then, we come to the watch trade. This watch, I am reliably informed, has a battery in it. So all the intricate files used by watch and clock makers that went tick-tock, tick-tock, aren't made anymore. They're not required anymore. So all the watch and clock files have gone. In fact, now I am reliably informed that this, with a time on it, is the method that most people use for knowing what the time is. I don't use a clock, watch or anything, I just guess the time and I'm never really far wrong. So that's the reason why files have been made for 2,000 years now, none, and the reason why none.
By the late 18th century, file making had become the primary tool trade in Sheffield. By the 1850s, well over 100 file enterprises were active in the town. At that time, about 4,000 workers were involved in file making, from a total workforce in the tool sector approaching 7,000. By the end of the 19th century, the Sheffield file industry surpassed cutlery as an employer. The file was the tool that was used to make other tools. Every industrial product needed shaping, and before the invention of accurate machine tools, files were used to perform this activity. This slide was taken from the 1849 White's Directory of Sheffield and shows well over 133 file manufacturers were active in Sheffield at that time. Many different file types were manufactured, and these were classified according to their shape. The standard types were flat files, round files, half-round files, triangular files, square files, knife edge files, and hand files. The slide shows a range of different types of files made in Sheffield. This display was produced by the File Trades Association, which was based in Sheffield. This association carried out research on behalf of the manufacturers and produced reports on this research. The aim of this association was to improve file making and to put it on a more scientific foundation. In the Hawley gallery, we have a number of the reports that were produced by this association, and they are worth reading if you are interested in file manufacturing. Files are also classified according to their tooth cut. There are 4 classifications which are referred to as bastard, second cut, smooth, and dead smooth. Files can also be single cut or double cut, where single cut files are generally used for hard metals. The raw material for files was good quality crucible carbon steel, containing 1.2 to 1.4% carbon and 0.1 to 0.13% silicon. Before Bessemer steel was invented, the steel was made by the cementation and crucible processes. It was first cast into ingot form, hammered down and rolled into bars, which were cut into short lengths, technically called moods. Next came the heating and forging operations, where the file tang was formed and the final shape of the file produced. This was known as a file blank. After this process came annealing. Forged blank needed to be annealed to soften and make it ductile so that the teeth could be cut without difficulty. The next phase in the processes was grinding, where the surface of the file blank was cleaned and made smooth and flat. Files may be hand ground or machine ground. At this stage, the teeth were cut. Until the late 19th century, file teeth were cut by hand. After that, file cutting machinery started to be introduced into the file manufacturing companies, although specials were still needed to be cut by hand. Hardening of the file was the final operation in order to produce the desired degree of cutting hardness, without which it would be too soft to do its work efficiently. The files were immersed in a heated lead bath in order to reach the desired hardening temperature of between 750 to 850 degrees Celsius. The files were then plunged into a brine bath to harden the files. Brine produced a rapid cooling known as quenching. As mentioned earlier, high-quality crucible tool steel was used for making files. The chemical composition of the steel was about 1% carbon, 0.2% silicon, and latterly a small amount of chromium was added. This steel had important properties for the filemaker in that it could be annealed and hardened. This slide shows the cementation furnaces at the Norfolk works of Thomas Furson's son at about 1900. The cementation furnace was used to convert iron bars into blister steel. The process involved surrounding the iron bars with charcoal and then heating these to about 1000 degrees C. The process was continued for 6 to 8 days, during which the carbon from the charcoal was absorbed by the iron on the surface of the bars. The bars were then known as blister steel, due to them being covered in small blisters. The bars were also very brittle and needed to be further worked by forging into shear steel or double shear steel. There are examples of these furnaces, one being in Sheffield on Doncaster Street, and the other being at Rowlands Gill near Newcastle, which is known as the Derwent Coat furnace. In the 18th and 19th centuries, Sheffield employed over 200 of these furnaces. It's worth noting at this stage that the steel produced was heterogeneous, with carbon steel on the surface of the bar and iron in the centre, where the carbon had not penetrated. This problem with the steel caused Huntsman to look for a solution, and as a result he invented the crucible process. In the early 1740s, Benjamin Huntsman moved from Doncaster to Handsworth. Handsworth was then a small village about 4 miles from Sheffield. This slide shows an image of Huntsman's cottage. The premises were demolished in the early 20th century, but there is a blue plaque on the wall of a house directly opposite the entrance to Asda, where the cottage used to stand. It was reported that flue marks could be seen on the small building at the end of the cottage, so this may be the place where the production of cast steel started. By 1751, Huntsman had sufficiently mastered the art of making crucible steel that he was able to give up his clockmaking business and to set himself up as a steelmaker. He moved to premises he had designed himself on Workshop Road in Attercliffe. This slide shows 2 images of the steelworks in about 1850, where the cementation furnaces and crucible workshops can clearly be seen. By this time, Benjamin Huntsman passed away and the company was run by his descendants, making high-quality crucible, tool steel and alloy steels. The alloy steels were known as Ajax steel. One of the major challenges in the production of crucible steel was the need to make crucible pots made from clay that could withstand temperatures of around 1600 degrees C. It is thought that one of the main reasons that Huntsman moved to Handsworth was that it was close to Catcliffe in Rotherham, where glassmaking was well established and where the technology of pot making to withstand high temperatures was well known. This is an early example of technology transfer. The crucible pots had to be relatively light so that they could be lifted out of the furnace by the pullers out and could be teamed into the mould by a teamer. A pot could contain up to 70 pounds of steel. They also had to withstand temperatures of 1600 degrees C for an extended period of time, and they also needed to be used for a number of different casts. The pots were made out of a special clay mixture. Sheffield steelmakers kept the composition of the clay secret, although it is thought that the ingredients used were Stourbridge clay, Derby clay, Stannington clay and Coke Breeze, or what was called grog. The mixture was now moistened with sufficient water to make it into a stiff mixture. It was then placed in a treading trough. This process involved workmen treading the clay in their bare feet for up to 4 to 5 hours to make the mixture homogeneous and to drive out air bubbles when trodden into a thin layer. Coated lumps, each sufficient to produce 1 pot, would then be boiled up, ready to be placed in what was called a flask made from cast iron, whose internal shape was that of a finished crucible pot exterior. The moulding operation consisted of throwing the cylindrical shaped rough piece into a cast iron mould known as a flask, whose internal shape was that of the finished pot's exterior shape. A cast iron plug was then pushed into the mixture. The plug's external shape was that of the finished pot's internal shape. After a few more operations, a finished pot was made, which was removed from the flask. The image showed rows of finished pots and a workman pushing a plug into a flask to produce a pot. The cross-section of a crucible furnace is shown. It is taken from Harry Brearley's book titled Steelmakers. The main components of the furnace are clearly labelled and are the cellar, the crucible pots, the actual furnace itself, and the chimney stack. An excellent description of the operation of the furnace can be read in Harry Brearley's book. An excellent example of a crucible furnace can be seen at the Abbeydale Industrial Hamlet. The feedstock for the crucible pots was blister steel produced by the cementation furnace. These were broken into smaller pieces. Alloying elements could also be added at this stage. The operation continued until the blister steel was fully molten and the mixture was completely homogeneous. This process usually took around 4 hours. When the molten steel was ready for pouring, the crucible pot was taken out of the furnace hole by a workman called a puller's out. The steel was poured out of the pot into a cast iron mould by a workman called a teamer. When the steel had cooled, it was taken out of the mould and then worked by forging or rolling into usable bars suitable for items such as files. Now that the steel had been made and the steel bars produced, I will turn my attention to the actual manufacture of files. This is a small section of a video made by Ken Hawley showing how files are hand cut. The complete video can be viewed on the Hawley YouTube channel.
By the way, that one in particular, you can see where the wear of the user's thumb has worn it away, and we have several hammers like that to show how much wear these things have had. So here we start. Bouncing, you see. Ooh, I nearly did it. That's the effect. Very poorly done, because they're one-sided and they shouldn't be, and also they're too widely spaced. I know that, but this job is a case of practice makes perfect, and I haven't practiced, and it's by no means perfect. I know that. Oh, stand that there. See if I can do a bit better this time. You've got to feel it, and that's half the job, sort of thing. I was just thinking, by God, you're doing good, Hawley, and then all of a sudden I missed strike. That's better. Now then, I think I've got it. I should have my elbow tucked in so it don't move, and I didn't. So I'm learning all the time because I forget. These are affecting me now, these things here. I'll do a stand the other side. If you want to do some on here? Yeah.
The steel bar was first heated to a forging temperature and then subjected to 2 forging operations, first to produce what is known as a mood, and then further heated and forged into a file blank. The file blank is the finished shape of the file, including the tang. The tang is where the handle fits. The file now has to be softened by the process of annealing so that the teeth can be cut, after which the 2 faces of the file are ground to remove any scale resulting from the forging and heating operations and to make the file faces smooth and parallel to each other. In the early days of file making, grinding was done by hand. Only 1 file could be ground at a time. Later, grinding was carried out by machine, where multiple files can be ground simultaneously. Special files are still ground by hand. Until the late 19th century, files were cut by hand. A highly skilled worker or file cutter sat with knees either side of a stock, which could be a stone block or wooden pillar. Into the top of the block or pillar, a steel block or stiddy was inserted, rested on a bed of horse manure in order to reduce the recoil from the hammer blows and also to locate the stiddy. The file blank was placed on the stiddy and held down by leather straps which were tensioned by looping it round the worker's feet. To further reduce the recoil, the file blank was placed on a bed of lead, which also was used to protect the teeth on the side of the file which had already been cut. The file cutter used a series of rapid blows with a specially shaped hammer onto a special chisel which was used to cut a tooth. 1 tooth was cut at a time at a rate of 60 to 80 blows a minute. Harry Brearley states in his book Talks on Steelmaking that a file cutter could cut 50,000 teeth per day. Hand cutters not only maintained an evenness and steadiness in the individual cuts, but also varied the force of the blow to cut various types of files, which were explained earlier in my presentation. As mentioned in the previous slide, hand file cutting was carried out by the file cutter using a specially shaped hammer and a specially shaped chisel. Hammers varied in weight, and the correct hammer was selected to provide the necessary force to produce the type of file being made. The shape and size of the chisel also needed to be carefully selected to suit the tooth profile being cut, and also to match the width of the file blank. The cutting edge of the chisel is placed at an angle to the longitudinal axis of the file blank. It is also inclined to the surface. By penetrating in this way, the chisel raises a burr with a sharp edge. The tops of the burrs are eventually removed from the finished file using a well-hardened file. This slide shows an engraving taken from the Illustrated London News published on the 10th of March 1866. It shows a typical hand file cutting workshop in Sheffield. 3 hand file cutters can be seen, with a large window in front of them to give them plenty of light. A workman pouring lead into a mould can also be seen. He would be making the lead beds used in the cutting operation. Women were also involved in file cutting, as can be seen on this image. This image has already been seen, but it is worth showing it again. Some time ago, a gentleman called Richard Herring visited the Hawley gallery and looked at the file display. He saw this photograph on one of the interpretation panels and instantly recognised it. He informed one of our volunteers, Michael Pilkington, that these were the hands of his granddad, Mr. Daniel Hudson, who was a hand file cutter for the Sheffield company of Samuel Peace. He informed us that this photograph was used by the company for marketing purposes. I am now going to turn my attention to machine file cutting. File cutting machines were introduced into Sheffield's file manufacturing companies in the middle of the 19th century. However, the first ever concept of a file cutting machine was originally thought of by Leonardo da Vinci in the early 16th century. A sketch of this machine taken from Leonardo's manuscripts is shown on this slide. As far as I am aware, this machine was never built. Max Medhurst, who was an engineering undergraduate student at the University of Cambridge, built a replica of Leonardo da Vinci's machine for his final year project. The university donated this machine to the Hawley tool collection, and it is now on display in the Hawley gallery. In the process of making files, machines were designed to replace the hand file cutter. A number of Sheffield companies manufactured file cutting machines. Walters and Dobson Limited of Bailey Street, Sheffield, was one of these companies, and this slide shows an example of their advertising material, illustrating their expertise in this field. Two file cutting machines made by Walters and Dobson are shown. The one shown on the left is the smaller of the two and is displayed in the Hawley gallery. The machines embody four basic elements. These are a chisel contrived to strike a number of swiftly repeated blows on a file blank, moving automatically forward so as to present a fresh surface to be cut or grooved at each blow, the rate of movement being such as to ensure that the spaces between each groove or cut are uniform. Second, a holder carrying the file blank. Third, a strong frame. And fourth, an adequate and firm foundation. This slide shows machine file cutting taking place at Camel Laird in Sheffield and William Hall Alma Works situated in Barker's Pool in Sheffield. I'm not sure which company the fourth image on the bottom right represents, but I've included it as it gives a good close-up image of machine file cutting. I will now turn my attention to the last file manufacturer in the UK. Alfred Ralston began business in Sheffield in 1913 as a general engineer, making engineers' tools, including files. The business started in Rockingham Street, Sheffield, and remained in the same location for 76 years. After Alfred's death in 1929, his son, Alfred Hurst Ralston, continued the business, being joined by his three sons, Donald, Jack, and Scott, with Jack becoming managing director and chairman. Under Jack's leadership, the company, as a quality file manufacturer, prospered, and it became the last file manufacturer in the country. In 1991, the company was sold to the American toolmaker Siemens Industries Limited, as it was unable to compete with cheaper foreign imports. File making has now totally disappeared from the UK, and files are largely made in India, where labour costs are much cheaper. It is interesting to note that Jack worked as a consultant in India to establish the file making industry in that country. High quality files are still made in Switzerland. This slide shows three images of the Ralston file manufacturing works. The image shows the stockyard where the steel bars were stored, the forging furnace where the file blanks were heated before forging, and a workman using a forging hammer to forge the blanks into the finished file shape, which included the tang. This slide shows two close-ups of a file cutting machine in action at Ralston's. The head of the machine can clearly be seen where the chisel is held, and the bed of the table on which the file is located. In 1842, the company of Thomas Firth and Sons was founded by Mark Firth and his brother Thomas Firth. The company started as a steel smelting works at Portobello Works on Charlotte Street, Sheffield. In 1849, a new works was begun on Savile Street, and this became the Norfolk Works. The manufacturing facilities included a large new file works, crucible furnaces, and rolling mills. In 1930, the company merged with John Brown and Co. to form Thomas Firth and John Brown, which was commonly known as Firth Browns. The following 3 slides illustrate the file making facilities at Thomas Firth and Sons. Next slide. The company established in 1849 a large new file manufacturing facility on Savile Street. The company made high quality cast steel using the crucible process, and this was used to make files, saws, edge tools and sickles, as indicated in the advertising material. 4 images of the file manufacturing facilities are shown in the order the processes would have been carried out. Starting from the top left, these are file forging, hand file grinding, machine file grinding, and file cutting. Continuing with the processes, these are shown on this slide, starting with file hardening using a lead-filled bath, examining the finished files, storing the files in the warehouse, and finally packing the files for the customers. In addition to the standard files made in Sheffield for production purposes, it is important to note that a rare class of files also existed which did not appear in any trade catalogues. These were known as exhibition files, which were made to showcase the worker's skill or advertise a manufacturer's wares. The leading exponent of the exhibition file in Sheffield was a man named Hiram Younge. This slide gives brief biographical details of Hiram Younge and the companies that he worked for. Hiram Younge made a number of exquisite exhibition files while working for various file manufacturing companies in Sheffield. These included a 10-inch file made for Ibbison's depicting the Globe Works, a 32-inch file for Turton's Chatsworth House on one side, and on the other side Wentworth House, a 54-inch file made for the Great Exhibition in 1851 while he was working for J. and Riley Carr, although the file was commissioned by the Union of the Sheffield United Filesmiths. The file took 4 months to cut and depicts the Crystal Palace and the Sheffield Infirmary. He also made a second exhibition file for J. and Riley Carr, also to be displayed at the Great Exhibition. This file illustrates the Wesley College in Sheffield and Carr's Bailey Lane Works and Carr's Mark, which was a pointer dog. Young's next exhibition files were made for John Bedford and Sons, illustrating its Regent Works and Outerbridge Works and the Houses of Parliament. One of these files was displayed at the Pasha exhibition in 1855. If anyone wishes to see some of the files made by Hiram Younge, the 32-inch Turton file and the file he made for J. and Riley Carr are displayed in the Hawley Gallery. The 54-inch file he made for the Union for the Great Exhibition is displayed in the Kelham Island Museum. This file is in its original glass case and mounted on a spindle so that it can be rotated and both sides of the file can be viewed. In 1857, Dr. John Charles Hall, who was the physician to the Sheffield Public Dispensary, studied the diseases caught by file grinders and file cutters in Sheffield. He wrote a report on his findings for the British Medical Journal. This report is shown on this slide. In particular, he studied 7 cases of file cutters, and the results showed that all 7 suffered from an illness known as cachexia, resulting from lead poisoning. This was a form of cancer causing, among other things, muscle wasting, violent abdominal pains, serious colic and cramps, paralysis, and epilepsy. The final paragraph in his report states, "It would be occupying the space of this journal to little purpose were I to go on detailing case after case of poisoning by lead in the scores of file cutters that have been under my care." The death certificate of Hiram Younge in 1860 clearly states that he died from cachexia at the age of 43. I have included at the end of my presentation a brief section on the company of Weetman and Smith. This is of particular interest as the company was situated on the site where the Hawley Gallery is now. Weetman and Smith made crucible steel, files and saws, and operated from 1845 to 1914. What remains of the crucible shop is located at the side of the Hawley Gallery and is now used by Kelham Island Museum as a place for talks to school children and for activities mainly related to the history of crucible steelmaking. Advertising material for the company is shown on this slide. Also shown is an order for files. Weetman and Smith also got caught up in the Sheffield outrage. The company had installed machinery for grinding. This was seen by the union as a real threat to grinders employed by the company, and on Monday the 17th of January 1854, a charge of gunpowder was pushed up a drain pipe and exploded. As far as I know, no one was injured, but production abruptly ceased and the firm offered £100 for use information, leading to an arrest. This slide shows the Weetman and Smith crucible shop as it was when it was producing crucible steel, and the crucible shop as it is now, which is used by Kelham Island, as mentioned earlier, for children's activities. I hope that you have enjoyed this presentation and learned something about the history of file making in Sheffield. The file display in the Hawley Gallery is worth a visit if you want to see the Walters and Dobson file cutting machine and the exhibition files made by Hiram Younge.